Murugan sir, good evening.
Good evening, sir.
Good evening, sir. You are welcome, sir. You are welcome to the FDP. Good evening, sir. Let us wait for another 5 or 6 minutes, sir. Then we will begin, sir. Okay, sir.
Yes, sir. Fine, sir. Fine, sir.
Okay, sir. Okay, sir. Thank you, sir. Thank you.
Ah.
Thank you, sir. Thank you.
Okay.
Murugan sir, let us wait for another 2-3 minutes, sir. We'll start by 6:05. Okay, sir.
No problem, sir. No problem.
Okay. Madam, Shivashankari ma'am.
Yes, sir.
Shivashankari madam. You are
Yes,
ready,
sir.
na,
Yes.
madam? 6:05 sharply you introduce our guest, madam. Then we
Okay.
will.
Okay.
Okay, madam.
Okay, sir.
Okay.
Okay.
Thank you. Madam.
Yeah. Shall I start, sir?
Yes, madam. We can start, I think, because the guest is also waiting. No. We
Okay.
will start, madam. You please introduce, sir. Then we
Okay.
will. Then we will hand over the session. Okay, madam.
Okay.
You please
Okay.
introduce.
So, good evening to one and all. We are moving to the second session on this 5-day FDP. Let me introduce our speaker. So, Dr. S. Murugan sir, who is working as a professor in the Department of Computer Science and Engineering from the School of Computing in Satyabama Institute of Science and Technology. He has completed his ME Computer Science and Engineering with university rank, and he has done his PhD in the year 2013. He has nearly 21 years of experience in teaching as well as in R&D activities, and he is a member for various professional bodies like IEEE, IANG, CSI, and ACM. He has 40 plus publications in peer-reviewed journals and 3 patents, and he has also authored 2 books on data structures. And he has been invited for a guest lecture to the University of Mendoza, Argentina, for delivering sessions on web technology and machine learning. He has been acted as head of the department in Department of Information Technology from January 2014 to June 2015 in Satyabama Institute of Science and Technology. And he has also been acted as head of the department for the Department of Computer Science and Engineering from June 2015 to June 2018 in Satyabama Institute of Science and Technology. So currently he is heading software development from July 2018 in Satyabama Institute of Science and Technology. His current research area includes data analytics, image processing, and machine learning. 2 research scholars completed their research under his PhD guidance, and he has been actively involved in consultancy and research projects. So with this brief introduction, I request our speaker, Dr. S. Murugan sir, to take over the session.
Thank you, ma'am. Thank you. Good evening, one and all present here. Thank you for the brief introduction. Is my screen visible, sir?
Yes, sir. Visible, sir.
Yeah.
Visible,
Thank
sir.
you.
Visible.
Yeah. Thank you. So, good evening once again. So, my title for today's presentation will be about web scraping, right? See, today we have data everywhere. Everywhere we have data, right? To start with, last year, Google came up with an advertisement stating that we are hiring, right? Google is recruiting people, right? And below the advertisement, they also gave a caption that please don't send your resume, right? Meaning that what? They are hiring, but they don't want the resumes to be sent to their HR, right? So how they find the people, right? So it's pretty simple that right from our Android phones, almost as far as India is concerned, we were using the major market share is Android. Or whenever I try to log in or look for some information over the web, I'm signing with my Google, right? Let it be Analytics Vidya or Medium or whatever it may be, or some there we have now so many websites starting with sorry, I have the domain name ending with AI, right? So wherever we go, we are supposed to sign in, where we show our presence, we exhibit, right? We throw ourselves onto the web, right? So all the data ultimately ends up at where? With Google only, because when I start my browser, the ultimate thing that gets loaded is the Google search engine. So I start, even for Gmail, we start from Google search. Even for my campus website, I start from Google, right? So whatever activities I do, rather me knowing, our Google knows better than us. Okay, it has a lot of information with it, right? So that is how the data is being used, analyzed, heavily utilized. Okay. So even wherever I go, even if I look for some place in my Google, right, Google Maps, after 1 month you visited 30 days before at that place, what is your feedback on that? So many people are waiting for your review comments. Like that, we are getting the notification through our smartphones, right? So thing is, everywhere data, right? So even when this era of big data was launched, when we used to attend so many lectures, they used to say Facebook is having this much amount of data, Twitter is generating this much volume of data every day, every minute, like that started uh, propagating, right? So when all these things are there, what we do with the data, right? What are you going to do with those data, right? So we have been now doing effective analysis, right? Like suppose if I go to Amazon or Flipkart, if I look for one item, automatically it is suggesting me, why not you purchase this item along with this? Because the other people who have, the other people who have purchased is also have purchased these things, the recommendation system, because it has the data, it could be able to recommend to us also, right? So that may be a chance, because instead of buying one item, they are ending up with selling two or more items. Okay, ultimately it is a marketing thing, and we look on to comments, feedback, the opinions of so many people before we start purchasing an item or on an online item or whatever it is. Right? So everywhere data is there. From the research perspective, right? Or maybe on the marketing perspective as well, or what my competitor is doing. I want to do some sort of analysis. So where will I go for the data? So data is everywhere. Even if you go to the climatic control, we have the weather station data is there. But if I want to carry out my research in some climatic prediction or some sort of thing, I need data, at least a handful of data on a day-to-day basis, yearly basis, spanned over a period of years. Okay, and data could have been collected across multiple locations across the globe, or if my region is of some interest, right? Maybe one specific region. So where do I go for data? Right? Of course, we could be able to collect from legally by paying and visiting government offices. We could be able to collect the data. That is one way, right? The other way is when the data is available at open, right, publicly available. Why not I pull it on my own, right? So how I grab those data, right? So that is what we mean by a web scrap. That could be a web page, could be in the form of a table, in the form of links, in the form of RSS feed, right? In the form of like posts, like Twitter or Facebook, right? It could be a medical data, it could be a image data, it could be a video data from YouTube. YouTube also they are providing APIs for retrieving the comments and doing analysis on that, right? So I want to pull all this data. Okay, so that is how this session I have planned. So I'll be showing some theoretical aspect, and I also will show you some small coding part where you could be able to download the data locally onto your machine. So that is what my objective of this presentation. We will see what is web scraping, an introduction, then what about the data, how what are the various structures of data available, how I could be able to pull out, right? Even though the workshop or the faculty development program title is about signals and systems, this you could also able to pull out the data whatever you want from the required website, whatever form you require, right? So this data you could be able to use in any form, right? If you're going for visualization, you could in those visualization tools like Tableau or Microsoft Buy or Python or R, anything you could be able to use the data, right? So before I start with my research, any sort of prediction or analysis or any cleaning process or anything, I need data now, right? So how to pull those data in whatever format may be, how I'm going to get it. So I'll be using demo three types of or three varieties in which you could be able to pull down the data. So one is using LXML and CSS select, then Python, Peter with async input and output, and beautiful soup, that is BS4. So using three different techniques, how you could be able to pull the data, which one is comfortable, everything will be going through in this presentation, right? Okay. So what is web scraping? It is automated extraction of information, right? So I write some simple logic. I target a website. I try to pull the data, right? So I have to target. I have to fix. It is not dynamic, right? I should know some inside details about that website in order to pull the data, right? So whenever we work for analysis, we present a chart or anything, we need the tabular data. But the data which I'm trying to download may not be in tabular format. It may be unstructured like Facebook or LinkedIn, where I have images, I have video clippings, I have text, I have comments, I have likes, I have dislikes. So many things are there, right? A comment for a comment, and it is a recursive one. And nowadays, we are not giving the comment only in text. It is emojis, right? So even in WhatsApp and all, we started using tensor GIFs, right? So they are unstructured media, right? And from the archive, how could I able to pull the data, right? See, frequently the data is kept on changing, so the track changes, the website, right? So I'll be using a log in order to maintain how the data is getting transferred or altered or modified over a period of time, like GDAP, right? So in GDAP and all, we have the version control system. So how I'm going to pull the data from all these kind of sources. Okay. So this is a brief introduction. What do you mean by web scraping? Right? So example, right? Costing, right? How I fix my price, right? For example, I'm running a supermarket or a car showroom. How will I know what is the price they are claiming and what these people are going to claim, right? Uh, uh, how I'm going to compare between one cost and the another cost. If you suppose I'm going to purchase a laptop, right? So I may look for Dell or Lenovo or HP or whatever it is. Okay. So for a similar configuration, what is the cost of each and every item? I used to compare, right? So this costing comparison happens at all levels of market. Even when I go for fixed deposit or when I go for share, right? So this share and all, the Zero the company, I hope you people will be knowing that MD is quite famous in the recent times, right? So Zero they are giving a Python-based software where I just need a credential that I have to purchase from them. I'll be getting the log or the transaction details of all shares that is happening on that day, right? So I have a comparison. Which share should I buy? Which share should not buy today? Which share I should sell today? Or which share I have to hold? These kind of comparison, you need scrapping. But in Zero, they are giving the data on their own, so you need not pull the data, right? So when you go for telemarketing, contact information, right? So all our data are being sold. For example, even if you go to any online shopping, when you give your number and the next day you are getting started receiving calls from them, right? So bank, everywhere the contact information are being pulled out. Mainly this I forgot the app, right? So which we are not supposed to use here, but still many are using the app. We could able to easily grab all the contact information about them. Then text mining, reviews, right? Comments. So how a product is all about. Okay, so if you want to pull those data, then emotional details, right? So all these things we could be able to do that with the help of pulling down the data. Then post in social media, right? Tweets, Facebook, LinkedIn, WhatsApp. As of now, they are not giving any API, but Facebook, Twitter, LinkedIn, I could be able to pull down the data and I can do analysis on it, right? So then feedback, comments on products, Flipkart, Amazon are the best examples. Then ratings again, everywhere, even a movie, this IMDb. Hope you would have come across. right? So if I want to go look for a movie, first I'll be looking for the IMDb rating of that movie or a web series or whatever it is, right? Then the climatic conditions. Every day now here in Chennai, it's pretty hot. So what will be the climate tomorrow? So I could able to download and I write a small app so that in my mobile phone it automatically uh, prompts tomorrow this will be the temperature you plan for this. So that level of micro level of data handling we could be able to do if we are good in web scraping, because somebody is already doing. Why I also do the same thing? I get the data and do whatever I want on it, right? So with this data, what I can do? I can get a CSV file for processing, because I hope most of you are from EC background. You'll be working with MATLAB, right? So where you need to give input for doing some computation. You'll be interested in the images, you'll be interested in the signal data, right? So of course, if you want to provide the data, you need the data in some of these formats. It may be CSV, or it may be a Excel file, or it may be a structured XML database, extensible markup language, or it may be in plain HTML, or it may be a database, something like MySQL, or for handling unstructured data, we'll be having MongoDB, right? Uh, or any DB that supports unstructured information, right? And we also have the tools to convert the unstructured data to a structured one. Right? So unstructured is always refers to the multimedia content like images, audio, video, emojis, GIF, all these things, right? So whatever data I'm pulling out, I should be in a position to be in a representable form. And so more formally, navigate through the website or a portal for gathering or collecting the required information. A website will be having so much of information. So how we are going to collect all this stuff, right? Then you need to know the pattern, how that website is organized in order to pull down the data, right? So you have to define your logic, the business logic, where to locate, how to collect the information, and you should be in a position to know how the data is being represented in their website, right? It may be in zip format, it may be in RAR format, it may be in a table, it may be LI, or it may be href, it may be anchor, or it may be whatever it is. Or sometimes you're lucky enough to have the files in a CSV or XLS format itself. Where simply I could be able to download and do the processing instead of scrapping, right? So I have to navigate, scroll through, search through a website for gathering or collecting the required information, right? And I also should know the pattern, because just like that, I could not be able to download the required data. And if, for example, there will be so many tables in your page, but which table you are focusing on, which table is of interest to you, you have to identify that before pulling down the data. Okay? So the data could be a tabular, or it may be a free multimedia content. Need not be only text. I have given only text. It could be even images. It could be a PDF file, right? Or it may be in a plain, simple tabular content in the form of rows and columns, where you can be able to easily pull down the data at a single stretch, right? So today, apart from CSV, XML, RSS, and XLS, one type of data format is widely applied because of its nature of handling the data. It can handle any type of data. If it is CSV, it is only plain text, right? And it will be only the rows and columns. So if you are much worried about a different location, unstructured way, then this JSON is going to be handy, because this JSON template format could be easily read by any programming language. Okay, so, and this is very fast in downloading, very fast to read and write back, and it can represent any type of data because it's all reference key value compo, right? Or I could use some APIs. For example, if I want to download some of the posts in Facebook or Twitter or YouTube, I need to have some credentials. For that, they are giving authentication token, right? Some if access ID authentication token, then access to a specific uh, tag or hashtag or whatever it is. Right? So I need to download the rights to access those credentials, access token ID, right? And my credentials. So two things should be there in order to pull down the data from Facebook or Twitter or YouTube, simply for security purpose. So they will be giving the list of fields that are available, and I could able to easily pull down. Okay. Then ontology languages, OW, ontology web language, or SparkQL. It's again a query language, ontology based query language, right? But till now, even though you were in the Web 3, Web 4, all those stuff, this ontology based search is still a dream till now. Okay, it's still not so success because of lack of databases, and we keep on moving to other terminologies rather than developing these environment. Okay, so if I know OWL language, I still able to download those data. And finally, the data could be in metadata or micro formats. For example, Mendeley. I don't know how many of you have come across this Mendeley tool, which suppose if I'm writing a research article, uh, I might be thinking of one journal, right? Everything okay, right from abstract till conclusion, it's of course my own representation, right? But when it comes to this reference, it's the most irritating part, right? Uh, uh, I will be having my references in one template, but the journal, whatever I'm looking, or a conference, will be asking me in a different format. The author name, comma. Then some of the representation will include dot. Some of them will ask me to put double quotes. Some of them will ask me to write the journal J dot, right? Some of them will be asking me to give the volume number or page number or year or publication in BibTeX format, EndNote format, and so many other IEEE format, ACM format, Springer format, Elsevier format, Taylor and Francis format, so many formats, right? So bringing out a research article itself is difficult, and finally, this particular component, giving the citations, is a major task, right? So to handle all the situation, if I use this Mendeley, it is freely downloadable, or you can register over the web. It's a cloud-based environment. Where I give the article, it gives me the citation in whatever format I want. So this Mendeley helps us in bringing those references in a better way, right? So they store the data in an organized manner, like title, year of publication, page from, page to, number of citations, the journal, the impact factor, the publisher, publishing year, everything, each and every micro information you could be able to pull out if you are using Mendeley. So Mendeley is one of a useful tool for a researcher at the time of publication. And you also can upload your full paper over there. Of course, it is free, right? And whenever you want to have your own citation, you could be able to easily grab, right? So how to handle this metadata? Right. So these are the different types of data where I'm interested in different types of format. I will be in a position to pull up. Right. So when it comes to free text, I'll be just pulling the data in the form of paragraph, right? And the comments, feedback, rating, tweets, posts, right? All these things I'll be doing analysis. Right? To do this, what could be the matching patterns? It could be a regular expression, right? A regular expression will be in some predefined format, character followed by characters, character followed by a number, number followed by character, or sequence of integers, sequence of strings, or something like my email ID, my date of birth. All these things are different examples of a regular expression, right? So in your web page or XML, they are all pre-structured data, right? So in order to navigate through, iterate through, I need something called XPath, XML path, right? Where I will be navigating through these documents or parse these documents for carrying out some task, right? Or now we are having a beautiful websites, look and feel, right? How that look and feel is being brought into the website because of cascading style sheets or CSS, right? So by making effective use of CSS selectors, I could be able to surf, pass through the document and pull the data whatever I want. So this is an example of a XML document where I have dog food is the name of an element and type is an attribute, and for that attribute I have a value, right? It's a simple example of an element, right? So the manufacturer of that dog food could be some company ABC, right? Then I have another element contact, which has another child element address. Then which has the attribute class equal to India, that may be country equal to India. And then where it is located in Chennai. Even this address could have sub elements, maybe street, name of the building, pin code, city, state, etc. But for simplicity, I have given restricted to only one child element. Then date. Directly here I have the text and close the root element doc4. Right. So one record like this, I'll be having n number of records in an XML document. Right. So here food type is my root element or parent element. Under this, I have dog food type equal to basic, and these kind of information will be repeated over here with different type, different data. Then here I have another type which is equal to premium, and I can have any number of types. So altogether, if you want to pull this data or put in a CSV for the purpose of analysis or building a model, I need an XML, I need a CSV, or I need a data frame in order to achieve that. Okay. So this is one representation. The same thing, this is how the XPath, how it works. The root element is dog food. Then it has an attribute type. It has a child element, manufacturer. It has another child element, contact. It has another child element, date. You can refer here. Right? Manufacturer, contact, date. So 3 child elements and 1 attribute. Right? So when it comes to the element manufacturer, it has only text. It doesn't have any further subdivisions. So similarly, when it comes to date, it has the plain text once again. But when it comes to the contact, it is having another child. So I label it as element address. Right? It has an attribute and it has a text as well. Right? So here the root element I gave with a different color, the child elements are with another color, the attributes in one color, and the final text is in another color. Okay. So the XPath will be navigating in this format. Okay. Right. Or HTML elements. It could be a para, it could be a break, it could be a header, it could be a list, it could be an image, it could be a table with header, row, and data part. It could be an anchor with href. It could be a div, it could be a span, and like this, I have so many HTML elements. And if you want to have a complete list, I have given here the hyperlink where you could have all the HTML elements listed in a page. And for information, I could able to write a program, web scraping, to pull all those elements and keep it locally. Okay, or in the form of an Excel sheet, I could be able to develop. Right. So let us see how we could be able to navigate through the selectors, CSS selectors. Right. So here all these things are nodes. Dog food is a node, manufacturer is a node, contact is a node, and so on. Right? So I'll be passing through them. There will be so many href. I'll be looking for one specific href, or I want to pull out all the href or a table with some ID like that. Okay. So what are the types of CSS selectors are there? It could be a universal selector by giving star. It matches all the elements or fetches all the elements from the given document. Could be a type selector name by giving a name, the name of a tag, for example, manufacturer, address, contact, etc. Or it could be a name of a class. Okay. So we'll be giving div class equal to within double quote something, maybe some table or whatever it is. Okay. Or I could be able to div ID equal to some XYZ. So with the help of ID, I could be able to pull down the data. Or with the help of attributes we have seen, right? The class equal to, or by href equal to, whatever the attribute, I could be able to get the value, right? Or it could be some from this point, fetch all the 5 sub-elements. Okay. And sub-element should be of this type. Filter all those things and pull it out. So I could even also write script to pull out next 5 elements, next 3 elements, next 3 elements of this type. So to that level, we could be able to parse, iterate through an XML or HTML document and pull out the data. Right? This is context and target selector again in CSS. Okay. So only match the T when it is a child of an element. Right? So C itself is a criteria, and if this has to be a child, you pull all those things. Okay. And T, if it is a descendant, right? Antecedent, descendant follows that the criteria matches by C. Okay. Only the sibling, right? So only the adjacent sibling, only immediate to the next. Okay. Only all the siblings, irrespective of the order, the last one. Okay. So only if it is a child, only if it is the adjacent child, or it could be any child or sibling, right? And only if it is a descendant and matches the criteria. So in any way could be able to pull the selectors, right? So first of all, the selectors could be star, could be a name, could be ID, could be a class, could be an attribute, or it could be any sequence. So in that sequence, match the criteria, pull out, match the criteria, pull only the descendant, only the adjacent sibling, or all the right? So what is the workflow that is involved in a web scraping? So first I have to define what I want to do. I should have a thorough knowledge of the website or the URL or the address where I want to do the scrapping. Right? Fetch the URL, post the request, get the response, and the data will be in the form of HTML or string. Customize the data to the required output in the form of CSV or JSON or XML or whatever it is. Right? So web scraping with Python. So I'll be giving you with 3 flavors. One is through LXML and CSS select. Other one is with Async Io and PyPeter, and the last one with Beautiful Soup. Right. So before I proceed further, I brief here for some questions so that I'll be moving on to something different now, right from now. It won't be more of a PPT demo sort of thing. So any clarification, I brief here and I'll continue later. Any questions? Any clarity? I know it's pretty difficult at this time morning, right? From maybe probably from 8 to 3 or 4, we'll be working. Then another 2 sessions. It's pretty difficult, I understand, but still, if you have any queries, I'm ready to answer. Okay. So let me give some few websites, right? Is my browser visible to you? So I'm not showing you a PPT browser.
Yes, sir. Yes, sir. Visible.
Yes, sir.
Yeah, thank you. See, this is a website that belongs to United Nations Security Council. They used to pass resolutions every year on some agenda of their meeting. If you iterate this right from 1946 till 2022, all the resolutions are posted here. Okay. If you click any one of these things and you make a note of this URL, okay. Now, if I click that 2022 year, so these are the resolutions that are passed by United Nations till 17th March. Today is 21, and up to 17th March, these are the resolutions that they have passed. Okay. So I'm not bothered about what are the resolution, right? Now, keep these two things in mind. Now, let me show you the source code of this. Right, so this is the source code of this particular page. Okay, so now my initial objective is to pull out all these years and these hyperlinks. Okay, see, let me tell you the objective of this example. I have these 3 columns. Okay, now here I am getting only the year 2022, but I want all the resolutions that are passed between 1946 and 2022. All this data I want to put and I want to give in a single sheet. And later I'll be doing some processing on that. For example, I can do analysis how many resolutions that involves the country, for example, Afghanistan or Yemen, right? Or how many every year, how many resolutions they are passing. I need a count, right? Suppose if it is, if I think this doesn't have anything over India. So how many resolutions where the name India is occurring? Okay. I want to do this kind of analysis, right? Then see 2022, 1946, 2022, almost 70 years, 76 years to be more precise, right? So you will be going through this one by one. You copy this and you put in your Excel sheet. You do that. Is it? Yeah, you can do that. So here the thing is only 76 and odd records. Okay, you can do it. It's pretty simple. I can simply copy and do it. Okay. Now let me give another scenario. This is website Weather Underground. Okay, this is the name of this is the URL where they post everyday data. Right. So here you can see March 1 till March 21. Today is March 21. They have the data on the temperature, the dew point, the humidity, the wind speed, the pressure, and the precipitation, the rainfall. Okay, so this data I have taken for my location near my college. Okay, so you can see here Soringanallu is the location. In that there is a station by name. They have labeled it as VOMM. The name of the station that they have labeled it for the Soringanallur junction is VOMM. So this I have taken going through the website physically. Okay, and if you see, it is for the date 2022-3, meaning that I need the date-wise report of all the temperature for the month March and for the year 2022. Okay. Now today it's for this month itself, I have 21 data and the number of columns is somewhere 3, 6, 1, 2, 3, 4, 12, 12 plus 1, 13, and date 14 columns are there altogether. Okay, so 3 with temperature, 3 with the dew point, 3 with humidity, 3 with wind speed, 3 with pressure, and 1 with precipitation. Right. So I have altogether 14 columns that spread across 21 days. Right. Now here again for February I would have got 28 days. For January I would have got 31 days. Like this, I want to carry out a research maybe for predicting rainfall or predicting the temperature in a specific region that is collected over a period of time, maybe for example 10 years. Okay. So here I can simply give last year by March I could able to get the data for the same region. Right, it is getting loaded. Right now, for this, I'll be having all the 31 days. Okay, so here for the year 2021 and for the same March, I'm getting 31 days, right? Now just imagine last year I had 12 months, almost 365 days, and this is only one zone. Okay, like this, I have so many stations. Here I could be able to change. See here, this is airport station, like this, and you can see here VOMM. Like this much stations are there, right? So here at least 3, 6, 7 stations for 12 months and 365 days. So how we are going to do it? Will you go through one by one? And will you copy and paste all this data physically? Does it not a time consuming task? You will be doing the whole life only these things. Okay. Now here only Chennai alone, this is okay. Suppose if you are worried about the entire Tamil Nadu, entire South India, or entire India, or across the globe. Okay, so we have stations like this across the globe. I need to find only the names of these regions. If I collect it, then within minutes, I won't say in seconds, within minutes, I could be able to pull down all this data. Right? So I need to know only about these things. These patterns are going to be common, and I could be able to get the data. Okay. Right? So this is a place where you need the web scraping. And of course, I have downloaded a lot of data from this site using this logic and for my research. That's the difference. Okay. Like this, you have to go through the data that you are looking for, and you should be having programming knowledge so that you should be in a position to pull down the data. Okay. Now here, let me come to the source code later. For this page. This page also I need the source code. Okay. Now let me come over here. Let me inspect this. I hope my screen is visible. Okay. Now it's with good. Okay. So here you can see for this 2022 year, you can see the hyperlink. When I click this 2222, this is the hyperlink is going to get opened, right? And I'm going to get this particular screen, right? And I should be knowing how to go through this. It's pretty simple. You can follow this hierarchy. There is a div, there is a div, ul, li, h4. You can look for a combination whether is there any ul, li, h4 combo is there in the page. If it does not exist, you are lucky enough. Only thing you just UL greater than LI greater than L4 will solve my problem. I could be able to scrap all this data at a single stretch. Okay. Now, keeping these things in mind, let me go to my coding part. Okay. Now, see, this is the thing which pulls out this particular information in the form of HTML. Okay. So this is the web page. You can see the address over here. Okay. So you can see the address, the same address I have passed over here. Resolutions adopted Security Council 2022. You can see here. Okay, Security Council content, the URL, exact URL I have done. Okay, so response equal to, this is what I was giving you in this part. This one. So URL, I have got it. The request, yes, I know how to get the request using like this. And whatever request from the URL, you pull down and store it in a object, that is response. Okay, with this response, what we can do, we'll see later. Now let me so this is a simple Python coding. Okay, so I have used the library request. I have given the link. I know how to pull down the data using the get method, and the entire web page content is stored here in the response. Okay, now let me run this. The link is being fetched and you could be able to see the output over here. Yes, the entire source code of this page, now I could be able to scrap it. You can see here. Okay, for example, let me copy this. You could be able to find over there. Okay, or skip to main content. So this page, skip to main content. You can see href equal to hash main content, element invisible, element focusable, blah blah blah. Fetch here, here. And before that, okay, it right. So you can see all the text, whatever that is there. Even see, I could be able to bring this Unicode characters. So you can see here. So whatever information over here, I could be able to bring out locally with a simple 3 lines of code to be able to do that. Okay, so this is just a preliminary. Generally, how I could be able to get the data or pull down the entire source code from a website. Okay, let me make things slightly complicated. Okay, now here the request, and now here I'm going to do some extract some data from my page of interest. Okay, so to do that, as I already told you, I'll be working with LXML, giving the demo on that. So if from LXML, import the HTML library. Right? So I'm here focusing only on HTML, not about XML. So I don't want to do that. The same address, same, pull the data. Okay, so get the data in the form of a hierarchy. Okay, you can see HTML dot from string, from the response you focus the, or you generate the XPath for traversing. That is what here I'm doing. So tree dot XPath follow the title. Okay, so you can do either this way, or you can use CSS select. Both are going to do the same task. Only thing, the way I'm going to handle my title element is going to be different. Okay, so from the LXML, you get the data in the HTML and make it as a tree, and generate a parsable one using either by help XPath or by CSS select. With the both are going to do the same thing. Only thing, the representation is different. Okay, now here, what is my element tag? What is the text content in that? and what is the element, name of the element, okay, and what is the tag, and who is the parent for this tag. Everything now I'm going to get it here when I run this code. Now here I won't get all the website content. Now it is going to be restricted. Okay, so let me clear this and run once again. See, the tag is title and the title of the text. Now in the how exactly it is given in my code, title resolutions adopted by the Security Council in 2022 United Nations. This you can see over here, the title tag. Same thing. Resolutions adopted by the Security Council in 2022 United Security Council. The same thing, I am getting it here. Okay. So who is the parent for this tag? Is head. That also I can show it here. So title is a part of your head. So like this, I could be able to navigate, pass through each and every one of these elements. Okay. So now I know how to download a HTML page. Now I know how to visit or navigate through individual items. Next step is further complicated. Okay. Right now, here, okay, the same link, right? The same request, right? Okay. Now this part, I think I don't need it here. Now what I'm going to do here, I told you already, I want to pull out, let me close this. I want to extract all these links. Wherever there is a here, I need the link to be fetched for me. Okay, for that, I have already told you. LIH4 div. If this combo is there, just pull the data. Just scrap the data. Okay. Now here, you can see tree.css select A, right? And wherever A is there, you pull the data. Okay. Now here, for here it will be having all the links at a stretch in the form of a list. Okay. For every link in link, you get the href. Okay. So here, for example, I have so many href. Right. Apart from this 72 years, I'll be having other links also. For example, here I do have some links. Here I do have some links. Here there are links. All these links I'm going to fetch it right now. Okay. So let me again clear my screen. So here I'm not doing it. Give the link, right? I want all the links with ahref, pull it out. Okay, that is what I'm going to do. Okay. So here I'm calling that a method. So this is a module, small module. Okay. So this is a small module where I'm going to call it, and I'm going to get all the links that are available in this page. Let me run this. See, all the links, whatever there in that page, I have got it here, right? In the form of a link. So here you'll be having the link starting from 2022, 1946, and various other links. Okay. But when I told you, when I started, I told you that I want only the years. Sorry, I want only the years. I don't want any other link. I'm not bothered. I'm bothered only about years. Okay. So I'm going to improvise this further. The same method here, I have improvised it little bit. Okay. Here the same start URL, the response, the tree, everything. Okay. Now here in the base URL, right? Here you can see div ul li h4. Okay. Div ul li h4. If this combo, we have seen no c greater than t in our PPT, right? So first div should be there. That should be followed by strictly followed by ul, and that should be followed by li, and that should be followed by h4. Okay. So if all these things are there, then when you pull those tags, I don't want anything else. Okay. So for example, if you take this link, let me give monthly how it is given. Monthly highlights, huh? Okay, monthly is here. All right. Highlights of the Security Council. Here you have the word monthly, but when you talk about the AHRF, its parent is EM. It is not div, it is not UL, it is not LI. So this one now I will not fetch it. Okay. So like this, the other links may not be fetched, but this one will be fetched because here you have div and you have h3, so it will not be fetched. Okay, so you have ul, li, h4, even though they are there, but you have a child element h3 in between, so it won't be fetched. Okay, so like this, I'll be going through all my document, and I have to definitely there will be a unique pattern for that. Okay, so pull it out. So that is what. So this is the catch here. As far as this one is this particular statement. So the same kind of hierarchy will not be there for all the web scraping technology. Okay, so this is applicable only for this page. If you are going for some other page, there the sequence will be different. Unless otherwise you know the source code, you cannot do anything. Okay, so now if you have a pattern like this, div followed by ul, followed by li, and followed by h4, get all those links. Okay. Then in that you look for A and you look for H reference. So from the base URL, from the year link, get the attribute. Okay. So this will be my initial page, but in that I'll be having so many links. So I'll just attach it, get the link, right? And in that, if this is not a year, you can simply, even if that monthly or yearly or annually pulls out, that will not have the year component. So those will be discarded automatically. Okay. So only if it has a year, you append it. Otherwise, you can simply ignore it. Okay. So now let me make it URLs underscore. Okay. Now let me run this. See, now the output is pretty simple. See, this I'm getting because there are some links are matching this particular criteria, but since it is not a year, so I'm generating an error. I don't want all these things. See, now I have only 22, 22, 21, 20, and so on. Only the up to 1946. When you compare the previous output, you have something 1971. So many links you have got. Okay, see here some JavaScript links also have been fetched, some fakes, right? Whereas when I refined my scrapping, I'm getting only the link and the. So this solves my purpose. Now in my thing, I have all the year and their links I have fetched up. Maybe the presentation may not be neat now as of now because these are intermediate output. I just want to show you. Okay. So now what I have done is I know how to read a web page, how to pass through the web page, and how to pass through the required content. See, as I told you, I need only these years and the links. Now I have got it. Okay. Right. Now let me advance further. These codes, of course, will be repeated here, so I will not explain it once again. Right. So I have the code here. Now the thing is, for every year, I need to get the data. Right, like this. So here it has some 3, 6, some 9 resolutions are there. Like this, right? From 1946 till 2022, what are the resolutions are passed? I need to have it. Okay. For that, I should know how this particular table is organized because this format, no, every year they will be having the same content, same type of structuring only because they will be pulling out from the DB and it will be displayed here. It just keep on appending component. Okay. Or using the CMS only they will be doing. So the structure remains the same. So I need not bother. If I look for 1 year, every year it is going to be same only. So let me copy this particular component and search here. Yeah, I got it. So it is through a div and it has this class combo. So many things are there. Okay, this one, right? And of course, I need this link, this date, and this topic. Okay, so if I get this, my job is done for the year. I can get what is the agenda ID, when the meeting was held, and what is the agenda. Okay, so that is what I'm going to do over here. Okay, so the first part will be getting all the year URLs. Now I'm going further. Now I have got all the 72 years of data, 72 years links. Now have to go through one by one, year by year, and pull all the data, pull all the resolutions. Okay, so for that purpose, I'm going to do it here. The same thing, tree.csv div greater than table. So div followed by table should be my priority. Okay. Or if I want to more refine further, I can make use of this table name, tbody, and so on. Okay. So here, if more than one table satisfies this criteria, then I don't know. Okay. So I have to refine further. So I assume that there exists only one table that is prefixed with div. Fetch all those things. Okay. Now here, I have this thing. Now for every select, this table will be having TRs that we know. If I know the HTML structure, I could be able to pull the data. Okay. For every TR, there will be a TD, and TD will be having the final text. That is what I'm doing here. So I'm creating a dictionary. I know what is the year URL and what is the year. I just want to maintain the log. Okay. Then for this TR, fetch the TD. Okay. Now here for every number of columns, here it may be 3 columns, it may be 4 columns, whatever it is. You pull the data and add it to the resolution. Okay. I add it to the resolution dictionary. So I'll be having the column 1, column 2, column 3, etc. And keep on adding the resolution for every year. Okay. Now here, first I get the data. And here, see, if I start running all those 72 years, that you'll be getting the code over here, right? That itself will take a maximum 20 to 30 minutes. Let me not do that. So let me take 1 year, okay, and pull the data. So if you run this, it keeps on running, right? So I give the source code to the organizers. You can get the code from them and you can run on it. But for time being, let me take only 1 year. Okay. So let me run this piece of code. And here I'll be getting the output as a CSV file. So I'll be converting the data dictionary to data frame, and that data frame. So here I have got the resolutions.csv that is generated over here. You can see here 7/12 today's date. Let me open this. I got the data. The same resolution, the title, and the scenario or the reason. So here I'm getting junk characters because that is how it has been stored internally. Okay. So like this, I could be able to fetch all the data starting from 1946 to 2022, simply like this in the form of an Excel sheet. Is it not easy enough to pull the data? Okay. So if I start running, it just keeps on running. So I don't want to do that, but still I have given the code. You can run it leisurely simply by commenting. Yeah, you have to comment this, and this piece of code have to come over here. Okay, so you'll be doing the job. Yeah. Okay. Let me correct the code right now. It should be equal to, and this will be the final line, so that the data will be written on to resolutions. Okay, right. So now I know how to download a web page, how to pass through the web page, pull out the specific data, the region of interest from the website, and collects all such activities that runs across different links and pull out the data. So that is what we have done over here. Okay. Right. Let me go to the PPT briefly. So this is what we have done, the example, right? Let me see two more examples. Yeah. So this is the Undar website. Okay. So here the problem is in web scraping, this UN resolution website is not a big thing where the data is very minimal and I could be able to get all the data. But assume that when the data is sufficiently large, I told you, I want to pull the data across multiple stations. You can see those stations that I have given here, and I have commented it because if I start running all these things again, it is going to be a time consuming task. Okay, so I restrict for this demo purpose with only one station. You can uncomment and you can run later, right? So when I am running this, it is going across different months, different stations, different years, all these, and multiple data from 14 columns for every month. Every month 30 rows or 31 rows or 28 rows or 29 rows. That spans over a period of years across multiple stations. When such things are going to happen, we have the problem of time. Okay, so abruptly my program gets halted, or repeated requests might land up in some sensitive issue happening might over the website. They may block our our request. Okay, so to handle all these things, we have the beautiful concept of asynchronous IO, that is input output. That's the library supported by Python. So just pull that website, right? Pull that library, which helps us in pulling the data that across several hours, right? And my request will not be denied. I still able to pull the data, right? So I'm going to use Async Io, and here I'm using another library, Python P Beta. Okay, so it is again a scrapping engine or library, right? So here instead of CSS select, we'll be using the other terminology, and here I'll be using the concept of asynchronous. And this is the address that I have given you shown you in the browser. And here, if you see that station, it is dynamic because time being I have given only one station, but there are so many other stations which you can pull it. And here also this date can be dynamic. I have fixed it as 2022, but you can have another loop where the year ranges from 1947 to 2022, whatever it is. So it takes a lot of amount of time to pull all the data. Hence, we have to use async. And here I'm making the page to wait idle because while loading itself, you can see how long it took to load the data, right? And this is the selector, the table.dates. I have a class, right? There is a table. In that, I have a class called days. Pull it out. And in that, I'm bothered only about the data. Remaining thing, I will adjust on my own. Okay. So from the table.days, get the exact content, the data part alone. That is what here I am doing. So which element you are looking for? In that, you fetch the data, you fetch the element, attribute, whatever you want. So get all the data and write us in the form of a table using a pandas. Okay. So here only I am reading all those data and converting to data frames, and I keep on accumulating all the data into the data frame. And here this is maybe Chennai, but I worked it for pulling out all the data across multiple stations all over India. Okay. Now let me run this. So I'll be generated with the file india.csv only for this station, right? For this station itself, just imagine how long it is taking. Suppose if I have hundreds of stations multiplied by a year of data or years of data, just think how long it will take. For one station, 1 month, it's taking so long because the website is designed like that. So still executing. Yeah, done. And here I have the file. You can see the same data, whatever you have seen there. This is temperature, dew, the final one is precipitation, all those things. Okay. Or I can open it in a Excel sheet. Yeah, you can see the 21 days of data, the March month, the days, and the value. Okay, so like this, and you can give the station also. I'm printing it because when I do some analysis, I need the station and month, everything. Okay, so like this, you have so many stations, so many months, so many years. Just imagine what will be the size of your sheet. It will be lengthy enough, right? And for generating itself, at least it took 1 minute of my time. For how many stations, how many years, how many months, just imagine. So to overcome this only, I have given async IO. My objective is not to explain the code here, okay, but these are the ways in which you could be able to exploit the web. Okay. Okay. Then I'll stop with one final demo. Yeah, this one. Any idea who is this Guido van Rossum? Right? This gentleman is the author of Python. Okay, you can see over here. I was the original creator and maintainer, not this one. Somebody could have written. See here. So I am the author of Python programming language. See my resume, all the stuff he has written. Okay. Right. I am the author of Python programming language. Such a contributor. See how his website, and he had posted in GitHub. Such a simple thing, right? This itself is enough. Why he want to do all sort of fancy things, right? And he also has given how his name is to be pronounced in US, in UK, how it has to be written. That is what he has given here in this webpage. That's all. This is the author of Python, which we are enjoying it today. In a simple href, he has done. Okay. Now the thing is, I'm just going to get all the links of this web page using a beautiful soup. So that is my last example. See, pretty simple. In 4 lines of code, I have done everything. Okay. So let me go through one by one. Okay. So the website is this python.org/guido. Right? Request, get the text and import beautiful soup, get the document and print the same HTML content, and only 4 lines of code. I'm going to get it. See, I got it. I got the website. I am the author of, you can see the href, everything is being displayed here. Okay. Now let me advance this one by one. Right? Soup.title. So here I have this title. Now this statement alone is going to print for me. I'll comment this. I have got the title. Yeah. Okay. This warning, let us not bother about that. So I'm just focusing on my element title and I result. Okay. Now let me elaborate further. I just want all the links that are present in this page. So links usually are starting with a href. Okay. So a, in that I have the attribute href, get it and simply print it. If you want, you copy all those things, put it in a CSV file and do whatever you do some analysis. Now I'll be getting all the links. So these are all the links that are there in his page. Right? So if you want, you can get it and you can do whatever you want. So these are the demonstration that I want to do in this session. And in general, so with web caching, with web scraping, what are the things I can avoid? So instead of, now I have given the same website, the resolution or the weather underground, I have executed several times. So instead, I can make use of the cache and I can work on it. Okay, I try to do offline scrapping, right? Like now, initially I told you, you pull down the data in the HTML, just all the requests. From that request, you start doing so that you are avoiding repeated visiting of the site over and over again. Okay, then I told you about that underground, weather underground, right? It takes a lot of time. So if this I'm going to run locally in my machine, in this laptop, it will take hours together. Instead, if I put this code on a cloud, something like AWS or DigitalOcean or Python anywhere, right? When you run this code on the cloud, it will be running on its own. You can do other job. Okay, and don't do the scrap daily. Do it on a periodic basis, and focus on your output format. Which format you want? You want CSV or image or Excel or XLX or XML or JSON? Which format you want? Focus on that. Okay. So these are the general advices that we can go through whenever we go for a web scraping ethics. So this is the most important. As far as the UN Security Council website is concerned, there is no issues in that we can pull up. But when it comes to Weather Underground, I'm not sure whether it is a copyrighted material. I have the right to download the data, but still it is open. They have not given any copyright or anything, so I have the liberty to download, and I should acknowledge them. That is the only thing I can do, right? In YouTube and all, suppose you're adding some background. If that is a copyrighted material, then your video will be deleted. In Facebook, they are doing it intelligently, right? So whenever I try to download a material, I should take care of these copyright or patented content, right? If I'm using it, I have to properly acknowledge wherever necessary, or I have to get prior written confirmation from them. Okay, so prior written approval in order to make use of the, otherwise it will lead to some legal complication, right? And once you started doing this web scraping, there are chances that that particular target website might end up with denial of service attacks. Is one of a network security attack. Okay, so that is why you pull down the material locally and you start scrapping. So that will avoid device attacks, because suppose we know when these results are published, maybe SSLC or HSC, we know the register number. We have the methodology to pull down all the code, all the marks at a single stretch. So already the site will be slow. At the time of results, how the government sites behave, right? So when you are downloading, there are chances that denial of service might be there. And of course, the legislation, the legal issues I was talking about, and the sharing of data, we have to get prior permission, intimation, notification, or written permission that I'm going to do these kind of work on this data, right? Or rather, if these people, these website owners, they themselves can provide the data in the form of open source like JSON or XML or CSV, or something like YouTube or Facebook or Twitter, where they give APIs for download the data. When they give API, it is a legal document. I have all the liberty to use that content for my research purpose. I mean, I should not publish anywhere, repost or anywhere, but I can work around that data. So that permission I'm getting if I'm getting the APIs, or if they themselves, see, there are a lot of data provided by Government of India, right? You can download the data. So that is open source. Anybody can download it, and if it is for academic purpose, there is no point. There is you can simply acknowledge in your reference. That's it. Right? So the data.gui.in providing with lot of information in terms of JSON, XML, or CSV. Only thing, the frequent updation of these data is not being done in those government websites. Okay. So I stopped my presentation over here. If you have any questions, you can raise either in the demo part or in the PPT or whatever it is. So I'm open to questions.
Dear participants, you can ask the questions now.
So these are some of the references where I have navigated through for getting these content to work on it.
Any questions?
Hello, sir.
Yes, sir.
Hello, sir.
Yes, sir.
Sir, you can. It is my voice audible.
Yes, sir. Yes, sir. Proceed, sir.
Sir, this is Narendra Kumar from Madurai.
Yes, sir.
Actually, you quoted that if you use any if you any surfing Amazon like that, if you give the phone number, right? Next day we get the call from our next day we get the options, right?
Yes, sir. Yes, sir. Yes, sir.
Then how they can be Amazon is a web service provider, but how the ex party will we
Yes,
get
sir.
these datas?
By simply using this scrapping, sir. We can
And
just navigate
that way
through,
we are,
and we could be able to put that.
if you are using our username and login, then how they can be get our data? That is a first question. Second question is if I am searching something like that, then how they can automatically add up the relevant items to this one.
Yes, sir. Sir, all these things begin the scene at the web analysis is being done, sir, or your search pattern, recommendation pattern. All these things are already in place right now in case of Amazon or Google. See, for example, I search something in Google or Amazon for a laptop, for example. Next time when I go to my Facebook account, I could be able to see a recommendation from the leading laptop manufacturers. How these things are integrated simply because of the Google. Because everywhere we are signing with Google, all these algorithms are
Yeah.
integrated. When I'm at present when I'm showing interest on any one item, it is being reflected in every other page that I'm visiting. So
Yes, sir.
all these things are integrated, and behind the scene, the recommendation system is working in an effective manner based on my interest, based on my recent search. The recommendations are being done.
Is there is any solution to prevent this?
We should have a different account for different platforms. That is the only thing as of now. Because my Gmail account is same. Where if I go to Facebook or Google or Amazon, my email account is same. So through that only it is fetching all the data. And of course, when I'm browsing in my browser, every browser, let it be Firefox or Mozilla or Opera or Safari, they are asking our credentials, asking us to sign in. So once I do that, then even though if you have different IDs, you're open, you're exposed.
But thank you, sir. Thank you.
Yeah, thank you, sir.
Any other questions? Dear participants, you can ask the questions now.
Okay, if there are no questions, thank you.
Yes, sir.
I thank the organizers for giving me an opportunity to present a topic which is related to machine learning and artificial intelligence, but how to pull the data from a web programmatically. So that was the objective behind this presentation. This can be used for any kind of machine learning algorithms. You can explore, you can explain whatever you want, and you can predict as well. So that is the objective behind this presentation. So I thank you for giving me an opportunity. Thank you, sir.
Thank you, sir. Thank you very much, sir. Thank you, Suresh, sir.
Thank you, sir. Murugan, sir, thank you.
Thank you, Kannan, sir, Murugan, sir, and Suresh, sir.
Thank you. Thank you very much.
Thank you then.
Thank you very much.
Shall I leave, sir?
Yes, sir. You please, sir.
Yes,
Please, thank you very much for your
Thank you.
wonderful presentation, sir, for this session. We are very much thankful to you, sir. Thank you very much. Thank you, sir.
Thank you, sir. Thank you very much, sir. Thank you for the opportunity. Thank you.
Thank you. I request all the participants also to join tomorrow session by 4 o'clock. Okay. Thank you. Now you can. Thank you.